Hello everyone, this is Shashikant Ippargi again back with the new question. So today I have given a question on MATPI which was related with the Pentagon, and the question was to find the angle X. So this was a question that was given in today's MATPI group, where the expected thing was to find out this angle which is X, and it's a very regular pentagon where all sides are equal. Okay, it's a very regular pentagon that you can see from the diagram itself. So today we need to find out the value of this X. Now there are actually we can have two solutions. Okay, we can go for two solutions. I'll go for both the solutions, but first I'll go for a solution which is simple, but we require a trigonometry kind of a thing. We require a trigonometry kind of a thing. So let's see what can be the first solution that we want to go for. Okay, so the first solution can be like this. You just need to draw a perpendicular line from this end to this end. Okay, suppose call this end as I think they have used up to EFG, then we'll use it as G, and then drop a one more perpendicular from this end to this end. Okay, this end. So you can call this as like H, right? So I have not done anything very like unique thing. It's a very simple thing, because again we need to go for a Pythagoras theorem. Once we know that there is a kind of a thing which can act like a hypotenuse, then we need to convert this question into a Pythagoras theorem. So what I have done is that I have just dropped two perpendicular lines so that I can go for a Pythagoras theorem. If you understand this key, this length, suppose if for the time being, what I'm doing is that I'll take this length as we'll take it as A. So this length will also be A, because it is given in the question. By using or by looking at these two marks, we can say that this length is equal to this length. Means what? In the question it is given already ki ED is equal to DF. It is already given in the question. So what we have done is that let ED equal to EF is equal to A. This is what we have done. Now, if this is equal to A, then AB is also equal to A, because AB is also a side of a pentagon. So AB is also equal to A. So I can say that this length is also equal to A. Now, if you look at the figure like properly, then this exactly should come at the center of this AB. So if this length is A from A to B, then HB is nothing but half of AB. So I can say that it is A by 2, because AB is A. If HB is A by 2, then we know that HB is equal to DG, right? So here I can say that from figure, see how simple it is. From figure, HB is equal to DG, then it should also be equal to what? A by 2. The very simple thing that I've got here is that this is also A by 2. Fine. Now, once we have got the two sides of a triangle, which is a right angle triangle, then it is very easy to go for the trigonometric functions. So if you look at the diagram, or if you look at the triangle which is FDG, so I'll take the triangle FD and then G, then what I can say is that if X is the angle, then DG is opposite side. DG is opposite side. Okay, and FD is hypotenuse, and FD is hypotenuse. Okay, so DG is opposite side of X, and so if I am taking as angle X with respect to X I am talking about, then DG is the opposite side and FD is the hypotenuse. So we need to find out what is the relation between hypotenuse and opposite side. So it is very simple. We can use sine of the angle. So I can say that sine of X is equal to opposite by hypotenuse. Opposite by hypotenuse. What is opposite? Opposite is DG divided by hypotenuse. hypotenuse is FD. Then what is the value of DG? DG is A by 2. What is the value of FD? FD is A itself. It is given already. We have assumed it. So it is A. So from this, A and A will get cancelled. So sine of X is equal to 1 by 2. Now you need to find out when sine is equal to 1 by 2. So sine of 30 is actually 1 by 2. Okay, sine of 30 is equal to 1 by 2. So I can say that X is equal to sine inverse of 1 by 2. So X is equal to 30 degree. So what I can say from this solution that this angle must be equal to 30 degree. So this was the way, or this was one of the technique of using the trigonometric function, because I can see from the figure that I can convert this into a right angle triangle. And once we have the right angle triangle, then it is very easy to go for like the trigonometric functions. Okay, so this is the solution number 1. Solution number 1. If you want to go for trigonometric part. Okay. Now we'll go for the solution number 2. Okay. The diagram is something like this. You can see the diagram is something like this. Okay. Only this D, F, and B are the lines that they have drawn. Now we'll go for the second solution. Second solution, where what I have done is that, see, it is very simple. What I have done is that I have drawn this equivalent. Suppose if I call this as A, the length as A, if I call the length of AB as A, then exactly equal to AB, I have drawn a length from F to, we'll call it as again G, from F to G. So if AB is equal to A, then GF must also be equal to A. Okay. But if AB is equal to A, then this must also be equal to A, then this must also be equal to A, then this must also be equal to A. See how the things are running. Okay. And if you look at that, then from this end to this end and from this end to this end, it should be same length. It should be same length. So if you understand that this is equal to this is equal to this, then this must be equal to this. So this also becomes A. See how beautifully the things are coming out. So this also has to be equal to the same thing, that is A. So this is A, AB is A, ED is A, DF is A, DG is A. So here I can say that DG is also equal to A, then DF is also equal to A. So it is very clear that key triangle DGF is an equilateral triangle. Equilateral triangle. Very simple. Okay. And if it is equilateral triangle, then we know that this must be equal to 60 degree. All the angles of the equilateral triangle are equal to 60 degree. If this is 60 degree, we can very well understand that the angle F totally is equal to 90 degree. But angle F consists of, angle F can be written as angle X plus angle DF and then G, which is equal to 90 degree. But DFG is the angle of the equilateral triangle that we have formed. So angle X plus 60 degree must be equal to 90 degree. Then angle X can be very easily written as 90 degree minus 60 degree, which is nothing but angle X is equal to 30 degree. So you can find out that even by using the logic or by looking at the diagram itself, we can draw some extra lines and then we can create a new kind of diagram which can give us a very easy solution. And this one was also very easy solution. So if somebody is not good at trigonometry, then you can follow this method. Okay. So with this, we have solved the same question with two different perspectives, with two different solutions. So this is the way that we can go for the same question with different process of solution, and we can achieve that. So thank you very much for today. Stay home, stay safe.